Okay, so that's how much I am worth. Just 1,000. Okay, 1,000 whatever, rands, dollars, doesn't matter. Now after 1 year, okay, and let's say that the rate, okay, so I didn't specify, the rate is again 6%, but now it's compound interest. Okay, so look at what happens here. So after 1 year, okay, everything looks relatively the same. I'm still going to be worth 1,000 plus 6%, so 6 over 100 of 1,000. Okay, so I'm going to be worth, so what is that equal to? Okay, so this is, let's see, plus 60, so this is 1,060. Okay, now look at what happens with compound interest. Now in this second year, okay, so for the second year, the amount of interest that I receive is calculated based off of the amount that I received the previous year. Okay, so now instead of with simple interest, okay, so with simple interest, this interest was calculated from my original amount. Okay, so 6% of 1,000, 6% of 1,000, that's what I'm going to receive every single year. With compound interest, now this amount, so this amount after 2 years is going to be calculated according to this amount that I received. Okay, so now I'm going to be with the following. I'm going to have this 1,060, and I'm going to have 6% of 1,060. Okay, so you guys can see that every single year I'm going to add a percentage of the amount that I received last year. Okay, and this can go on into infinity. Okay, but this method of calculating how much I'm worth or how much the total amount is very tedious, because we have to, every single time we have to add the percentage of the previous amount. So there is a very nice formula that we can use to calculate the total amount at the end. Okay, and that formula is as follows. Let's just create some space. Okay, so it's A is equal to P times 1 plus R over 100 to the power of n. Okay, so can you guys see that this looks very similar to that formula that I showed you guys with simple interest? Okay, but now my time is an exponent. Okay, so this is again, this will be my time period. This will be my rate. And this is my principal. And this is my starting amount or my accumulated amount. So let's say starting or accumulated amount. Okay, it's very simple to use this formula. We know that if we want to find the total amount at the end of the entire time period, we just take the starting amount, which is P, okay, take the rate, substitute in there, and then I raise it to the power of the time period. Okay, so I just substitute the time period into this. Okay, now, again, it's very important to remember that this is not to calculate the interest, okay? This is to calculate the total, that final amount, okay, but not the interest. If I want to calculate the compound interest, and I'm going to give it, let's say CI, okay, so I'm making this one up, but this is compound interest. If I want to calculate that, then again, I would need to take my final amount, which is A, calculated, and I need to subtract the starting amount. Okay, so that's how I calculate my compound interest. Okay, so the interest, not the total amount. Okay, great stuff. Let's do an example. So, a man owes $5,000 on his credit cards. Okay, the annual rate is 20%. Okay, so I think this is annual. I'm not sure what the P is for, but APR is 20%. It's an annual rate is 20%. Okay, if he doesn't repay any of the debt, how much will he owe after 4 years? Okay, so normally credit cards are actually calculated monthly, but because they tell me that it's annually, we're going to calculate it according to the years that he's owing. Okay, so let's use the formula. So A is equal to P times 1 plus R over 100, and we raise it to the power of n. Okay, so what do we have? We have the rate, 20%. we have the principal amount, 5,000, and we have the time, which is 4 years. So it's plug and play, we plug it into the formula, and we will have it. Okay, so principal is 5,000, and we have 1 plus R is, let's see, 20%, so this is 20 over 100, and it's to the power of 4. Okay. I can actually explain to you guys how the formula works, but I don't really want to. It's going to take up a lot of time. Maybe we can do that in another session. But for now, we're going to plug and play, and we're going to calculate it. Okay, let's see. So it's 5,000 times 1 plus 20 over 100. Okay, we could have simplified this to 1.2, and we raise it to the power of 4. Okay, so at the end of 4 years, he would own, well, he will actually owe the bank. So this is $10,368. Okay, now just for interest's sake, how much will the compound interest be, or the extra amount be that he'd need to pay because he lent this amount? So to find the compound interest, again, don't cite me on the abbreviation CI. So the compound interest is equal to A minus P, or just this final amount, so 10,368 minus 5,000. Okay, and you can use this idea to actually calculate how much you are paying for something if you buy something on credit. Okay, so next time you take out a phone contract, see what the final amount is and minus the initial amount, so the cost of the phone, and see how much interest you're actually paying. Okay, but anyway, this was not part of the question, and they wanted to know how much he will owe after 5 years. Okay, so this is how much he will owe. Okay, so how much he will owe, and this is just the compound interest. Okay, and let's calculate this just for the notes. Okay, so we have $5,368. Okay, so he pays 5,300 extra just for lending that money. That's a lot of money. Okay. Anyway, let's do another question. So a shipping company borrows 70 million at 5% per annum compound interest. Okay, so all of those words are important. Okay, so he borrows, so the shipping company borrows 70 million. This is my principal, 5%. We have the rate. We know that it's compound interest, so we're allowed to use the compound interest formula. Okay, and let's see. So to build a new cruise ship, if it repays the debt after 3 years, how much interest will the company pay? Okay, so how are we going to do this? So we need to find that compound interest. Okay, so this is not like the previous question where we were required to calculate the total amount. We now actually have to calculate this compound interest. So that's exactly what we're going to do. We're going to calculate the final amount that this company actually owes, and then we're going to subtract my principal amount to find the interest. Okay, so let's go through the process. So A is equal to P times 1 plus R over 100 to the power of N compound. Okay, and let's plug and play. So my principal amount is 70 million. Okay, so that's a lot of zeros. And this is times 1 plus my rate is 5. So we have 5 over 100, and we raise it to the power of 3. Okay, so this final amount that I would actually owe the bank, or I'm not sure where they lent the money, but let's see. Okay, so it's 70 million, 123, times 1 plus, so it's actually 1.05, okay, and to the power of 3. Okay, so this is equal to, let's see, so it's 3 years, so we have 81 million, and I think we have 33,750. That's a lot of ands. Okay, you guys get the idea. So it's 81 million. Okay, so how much interest did the company pay, or will the company pay? So now, to get that interest, we'll say compound interest. Okay, or we can just say interest, it's fine. Okay, that's equal to A minus P, and this is equal to this final amount, so this 81,053,750 minus 70 million. Okay, but you guys can see that this is just equal to 11 million $33,750. Okay, and there we have it. That's the interest that we're actually going to pay. Okay, and just for interest's sake, to go back to this previous question, so APR is annual percentage rate. Thank you very much, guys, in the chat. Okay, stuff. Last question, you guys. I think we are running over time. So let's just do this last one before ending off. Okay, because this one is difficult. It's at an exam level, and we need to think very carefully. Okay, so Marcel invests 2,500 for 3 years at a rate of 1.6% per year, simple interest. Okay, so Marcel, he has an investment, 3 years, 1.6%, simple interest. Okay, now Jacques invests 2,000 for 3 years at a rate of X% per year, compound interest. At the end of 3 years, Marcel and Jacques receive the same amount of interest. Okay, so this is very important. They receive the same amount of interest. So purely the interest. Okay, calculate the value of X correct to significant figures. Okay, so let's break this up into information that we do know and don't know. So for Marcel, the amount of interest is going to be very simple. We'll just say that simple interest is equal to PRT over 100. Okay, and we can substitute the values, and it's relatively simple. So this is 2,500 times the rate is 1.6 times the time is 3 years, and we'll divide that by 100. Okay, so easily calculated, we have that simple interest. Let's see, so that's 2,500 times 1.6 times 3 divided by 100. Okay, and this is 120. Okay, so we have the simple interest. Now, for Jacques, this is again a situation where we don't have this amount of interest. Okay, so we don't know what that amount of interest is. So we can't really put that equal to anything. But what we can do is, let's just write it. So we'll substitute what we know into the formula for my final amount. Okay, so for Jacques, let's say A is equal to P times 1 plus R over 100 to the power of N. Okay, so this final amount is equal to, so this is 2,000 times 1 plus R is, okay, so we don't know what that rate is. Okay, this is the variable that we're after. Over 100, and we raise it to the power of 3. Okay, great. So this is how the final amount would look, right? But we're looking for the compound interest. Okay, so we're looking for the interest. And we know that, and I'm going to use this CI just to say that it's compound interest. We know that that's equal to the final amount minus principal amount. Okay, so we have a formula for this final amount. Okay, so what we can do is we can just substitute that into A over here. So this is 2,000 times 1 plus X over 100. And we raise that. Okay, so that's cubed. Minus, we know what the principal amount is, so that's just 2,000. Okay, the reason why I want this interest or this compound interest is because that they tell me that at the end of 3 years, Marcel and Jacques receive the same amount of interest. Okay, so that's the reason why I calculated these two separately. So now we can say that, let's use a different color, we can say that the simple interest is equal to compound interest. Right? We know that this is 120, and we have this expression for compound interest. So now we can substitute, and then we'll solve for x. Okay, so 120 is equal to, we have 2,000 times 1 plus x over, over 100 to the 3 minus 2,000. Okay, so let's simplify. So firstly, let's get rid of this minus 2,000. Let's just take it over to the other side. So this is 120 plus 2,000, and this is equal to 2,000 times whatever is inside this bracket. Okay, and now we have to be careful. Now we can't just start subtracting by 1 and weird stuff like that. We first need to get rid of this 2,000, okay, and we need to get rid of this cube. Okay, remember that if you want to solve for a variable and it's inside a bracket and you have an exponent, you first have to get rid of that exponent before you can look for the variable. Okay. So anyway, let's just simplify this. So this is actually 2,000 120. So 2, 120. Oops, and it's in whites, but it's fine. Okay, so now let's divide by 2,000. Okay, so we divide by 2,000. We're happy there. And I'm not going to simplify this. I'm going to leave it as a fraction just for now. Okay, so we have 2, 120 over 2,000 is equal to, we have 1 plus x over 100 cubed. Okay, how do we get rid of any exponents? Okay, we can just put a cube root. Okay, so any root with exponent, so if it was to the power of 4, we could have said root 4, but in this case, we're just going to use a cube root. Okay, so we use a cube root on that side to get rid of it, but if you use it on the one side, you have to use it on the other side. Okay, so great stuff. These cubes cancel out, and I'm left with, let's see, I'm going to copy and paste because I can. Okay, so let's group that, copy and paste. Okay, so we have that cube root of 120 divided by 2,000, and that's equal to 1 plus x over 100. Okay, and the bracket's not even necessary because they were just there because of the exponent. Okay, cool stuff. So now to solve for x, what are we going to do? We're going to take this 1 over, and we're going to multiply everything by 100. Okay, so again, we have this. Minus 1 is equal to x over 100, and we can multiply by 100. Finally, we get to the final step, and let's see what the total is. So x is equal to, and remember, we are multiplying this entire thing by 100. Okay, let's see. So cube root of 120 divided by 2,000 minus 1 and times 100. Okay, and this x is, okay, I did something incorrectly somewhere. Let's just make sure. Okay, cube root of 120 over 2,000 minus 1. Okay, that looks good. Times 100. Okay, there we go. Okay, so x is equal to 1.96%. Okay, 3 significant figures. We are happy. Sorry, guys, this algebraic process took a bit longer than I expected. But that's it. Okay, so the whole crux of this question is that the simple interest was equal to interest from compound. Okay, so from JOG. All right, that was the crux of everything. But we're happy. We solved for x, and we gave it to 3 significant figures. Right, guys, but that's it for this lesson. Thank you very much for joining. I will see you in a next one. Goodbye.